Back. I am now in your notes on page 11, it appears. Page 11, dealing with composite functions. Now, notice the first thing we have to talk about is this weird notation where it's got f of g. This is pronounced f of g of x. F of g of x. And this would be g of f of x, and f of x, and g of x. There is another way to write this that you may see out there. The book doesn't have it. The notes don't have it either, but you may on an ACT or if you're going to college somewhere, you may see this. It's called kind of looks like a fog, but this little half a zero in between there means composite. So it means f of g of x. Same thing as if you were to see GOF, I call it the GOF, g of f of g of x, you may see it written like this. So first we have to discuss this weird notation. So let's say that you had some function, we're kind of reviewing here, but let's say you had f of x equals 3x squared plus 2x minus 6. And I wrote this under here, f of 2. That means, and we've had this before, that you take this 2 and you come up here and everywhere you see an x, you put 2. So you would go 3 parentheses, because remember Mr. Palmer's rule of plugging stuff in, it says you have to put in parentheses, plus 2 times 2 minus 6, and you would solve and get something fun. What we're doing different today is now we'll have an f of x, like in example 1, I'm doing example 1, I'm just doing it on a different page. You have a 3x minus 2, and you have a g of x being x squared. What it means if you have f of g of x is you do the same thing you would have when you had f of 2, which is you come up here to your function and everywhere you see an x, you put this value. That is exactly what I'm going to do here. I'm going to start at my f, meaning I'm right here. I'm going to go through and start writing, meaning I'm going to start writing with a 3. And everywhere I see an x here, I'm going to put whatever my g of x is. Since g of x is x squared, I'm going to put that right there. Don't forget Mr. Palmer's rule of plugging stuff in. Make sure you put stuff in parentheses. And then I continue with my minus 2. There really isn't a whole lot to simplify there. So the composite function f of g of x would be 3x squared minus 2. So if I go back here, that's what this example 1 letter A would be 3x squared minus 2. Don't forget, we still are going to have this domain conversation. Domain, as we did on the previous video. The domain of something is simply, we've got true rules that you can't break, and this one doesn't break either of them. So the domain here is all reals. All right, g of f of x, this would be the GOF, and that's not a technical term, I'm just making that up, but it's pronounced g of f of x, meaning I would start now at the g, so I'm going to start right here. Everywhere I see an x, though, I'm going to put whatever f of x is. So right here I see an x immediately, so I'm going to put my f of x, which is 3x minus 2. Don't forget to put stuff in parentheses, and I have to square it. This does not mean you distribute the 2 in there. That's not what you do here. You have to make sure that you understand this is a 3x minus 2 times the 3x minus 2. Double distribute all that, you'll end up with a 9x squared minus 12x plus 4. That domain also doesn't break any of our rules, so it's all reals. All right, next one, let's do f of x. That means that I start here and I start writing. Okay, so I have a 3. Everywhere I see an x, I'm going to put this entire thing right there. So I'm going to go f, and then 3x minus 2, and then I still have this minus 2 on the back, minus 2. I'm going to do a distribute here. I'm going to put the 3 in there. Combine like terms, you should end up with a 9x, and that'll be minus 6 minus 2 more, minus 8. That is what f of x would be. The domain here does not break any of the rules, so it is all reals. And the last one would be g of x, where you've got to start here with your x squared, and everywhere you see an x, you put x squared. Making sure I put things in parentheses, I end up with an x squared squared, which is x to the 4th. Again, the domain here does not break either of my true rules, so it is all reals. All right, let's do one more example, and then we're going to have some checkpoints, some tries down here at the bottom. So, example number 2. f of g of x. I'm going to start here, and everywhere that I see an x, I'm going to put x minus 2. So I start writing with a 2. Now I immediately see an x, so I'm going to have to put an x minus 2, making sure I put it in parentheses, to the negative first power. You do not distribute this negative 1 in here. Negative powers from the previous videos means that you take and put this entire thing right here, because that's immediately to the left, and you put it on the bottom. So you end up with 2 over x minus 2. This 2 stays on top. There's my final. The domain here, this one does break one of our rules because you can't have 0 on the bottom. So it's all reals, except I'm going to set x minus 2 equal to 0, so x equals 2. This cannot happen. So you would say all reals, except x cannot be equal to 2. Because if it is, then that whole bottom there would be 0. All right, let me go to a different color here. Let's do g of f of x. So now I do the same thing. I'm going right here, and everywhere, I'm going to rewrite this, and everywhere I see an x, I'm going to put in 2x minus 1. So I see an x right away. I got to go 2x to the negative 1, in parentheses, minus 2. Negative powers of x you bring down. You leave this 2 up above, so it is 2 over x minus 2. This also breaks one of our rules for the domain, because it is all reals, except you can't have 0 on the bottom, so you set this bottom equal to 0, so x can't be 0. Kind of. G of x, starting right here. Everywhere I see an x, I'm going to put x minus 2, so I get x minus 2 minus 2. Simplify, you get an x minus 4. The domain here does not break any of my rules, so I'm good. It's all reals. And the last one is f of x. I start here with my 2x minus 1. I start writing, and everywhere I see an x, which I see one right there, I put 2x to the negative 1. Take that to the negative first power. This one, you can distribute the negative 1. Up here, you could not because it was being subtracted. Down here, because everything's multiplied, yes, you can put this negative 1 in there. So don't forget your 2 out front, and then you'll have 2 to the negative 1, x to the first. Because if you go back a couple videos, power to a power, you multiply. Negative powers you put on the bottom. So you end up with 2 over 2, and then don't forget you got the x up here. These will cancel out, and leave you with an x. Domain here. A little bit tricky, but because of this negative 1 here, yes, I know that it eventually canceled out, but because of this negative 1, that means you can't have x on the bottom. So again, we have our x can't be equal to 0 here for our domain. All right, so a couple examples on how to find composite functions. What I want you to do now is I want you to try these checkpoints. These 4 problems here, the first ones we're adding and subtracting from the previous video. And here's all your composite ones. I will put the answers to these online so you can check yours when you're done.